Mutually exclusive events are events that can't happen at the same time or do not have an influence on one another, such as tossing a coin and rolling a dice. So what I mean by that is if I was to toss the coin and get a head when I land on a coin, whatever I roll on the dice is not influenced at all by whatever result I've gotten for the coin. So why I have this is called the OR rule is usually when we're dealing with any kind of probability in relation to mutually exclusive events, we're dealing with the probability of getting one event or another event. So probability of getting a 6 on their dice or the probability of getting a heads on the coin. What is the probability of both of those happening, essentially? So we do something, it's also called the addition rule. And the reason why is because generally we use the probability of whatever the first event is multiplied by the probability of whatever the second event is. Or added, by the probability of the second event. That is generally our rule, if they're mutually exclusive, because there's nothing that is coinciding between the two. So an example of this would be if I had this set of cards, so the probability of drawing a red card or an even number. So we would look at the probability of drawing a red card or an even number would be the probability of drawing a red card plus the probability of drawing an even number. Now, probability of drawing a red card, we know that's 4 cards out of 7, so we would say that's 4 out of 7. The probability of drawing an even number is only 1 out of 7. So we add those two together and we're going to get the probability of a red or an even card is going to be 5 out of 7. Now, the thing about this, what you will notice is the even number, the 2, is on a black card at the moment. So there's no overlap between red cards or having an even number. There's nothing there. Whereupon, if we scroll down here to our second example, we're looking at same 7 cards, different numbers. And what we do notice is that one of the red cards has an even number on it. So in that case, the probability of having a red card and the probability of having an even number, they're no longer mutually exclusive events because they can both happen at the same time or they can both influence one another. Okay, so if we were to then find the probability of a red card or an even number, or an even number, we're looking at the probability of getting a red card plus the probability of getting an even number. Probability of getting a red card, so we've got 1, 2 and 5, so that's going to be 3 out of the 7. Now our even numbers, we've got 2, we've got 6 and we've got 8, so that's going to be 3 out of 7 as well. However, what we will notice is those 3 cards, so 1, 2 and 5, they're all red, but that 2 has been used twice. When we've got the card that's used up twice, we don't really want that because we're counting it twice in our probability, which is going to invalidate our results. So what we need to do is take out what has both. So we're going to, instead of adding, we're going to take away the probability of both, which is red and even. In this case, that's only one of them out of the 7, so we're going to say take away 1/7. So we are going to have 3 7s plus 3 7s, take away 1/7, which is going to give us 5 7s, which is the probability of red or even in this case.